Hello and welcome back. In today's video, I'm overclocking the AMD Radeon Graphics integrated in the Ryzen 7000 CPUs all the way up to 3.1 GHz using the GIGABYTE B650E Aorus Tachyon motherboard. Overclocking the integrated graphics of the Ryzen 7000 CPUs was not supported at launch. However, with AGISA 1004, AMD has included the toolkit needed to overclock the integrated graphics. Now, I want to warn you up front, overclocking the integrated graphics does not all of a sudden turn it into a viable option for gaming, right? It's still going to be slow. But I wouldn't be a SkatterBencher if I wouldn't try to overclock it anyway and see what the performance improvements look like. All right. We have quite a bit of topics to cover, so let's get started. As I mentioned in my Rafael Overclocking What's New launch video, every Ryzen 7000 CPU now comes with integrated graphics. While technically that should make it an APU, AMD still calls these processors CPUs. There are a couple of differences between APUs, real APUs, and the Ryzen 7000 CPUs with integrated graphics. First, the graphics cores are integrated into the I/O die. That's a separate chip from the CPU core dies. And that's different from APUs, where everything is integrated into a single die. Second, the graphics on Rafael are not meant to run any kind of 3D load. It of course can, but the performance is pretty terrible. In my launch video, I pointed out that there were no overclocking options for the integrated graphics, and I even went as far to say that it's unlikely that it would be supported in the future. Clearly, I was wrong, because since AGISA 1004, we have the tools in the BIOS to overclock the Ryzen 7000 integrated graphics. The AMD Radeon Graphics, Ryzen 7000 integrated graphics, features the reasonably modern RDNA 2.0 architecture in its smallest form. The Ryzen 7000 CPUs get exactly one work group processor, or WGP. In RDNA 2.0, one WGP encompasses two CUs, or compute units, as well as two ray tracing accelerators. To give you an idea of how little compute that is, the AMD Ryzen RX 6500 XT we overclocked in SkatterBencher number 41 has 8 WGPs. And that's the most low-end RDNA 2 discrete graphics card you can buy in retail. Even the weakest RDNA 2 notebook APU, the Ryzen 5 6600U, has 3 work group processors. Another obvious difference between the RDNA 2 discrete graphics and the Ryzen 7000 integrated graphics is the memory, as the latter relies on the system's DDR5 memory. If you want to learn more about the Ryzen 7000 IGP cache and memory bandwidth limitations, I highly recommend the Chips and Cheese article titled AMD's Zen 4 Part 3, System Level Stuff and iGPU. Overclocking the integrated graphics of a Ryzen 7000 CPU is actually very similar to how it works on AMD APUs, and we'll cover that in OC strategy number 2. In total, we will cover 3 different overclocking strategies in this video. First, we leverage AMD's PBO and EXPO technologies. Second, we manually increase the GPU frequency in the motherboard BIOS. And then third, we maximize the GPU overclock using GFX Curve Optimizer. But before we jump into the overclocking, let's first have a look at the hardware and the benchmarks that we'll be using in this guide. The system we're overclocking today consists of the following hardware. We use Windows 11 and the following benchmark applications to measure performance and ensure system stability. The benchmark selection is similar to the ones that we used in the last AMD GPU SkatterBencher video, except for the reintroduction of AI Benchmark and Handbrake, and the addition of Nero and Easy Bench. For AI Benchmark, since AMD ROC-M is not available on Windows, I rely on TensorFlow DirectML. I showed how to set up this benchmark in another video on this channel. For Handbrake, I use the VCN 1080p setting. VCN stands for Video Core Next and is AMD's brand for video encoding and decoding hardware. Nero Score is a relatively new benchmark available on Steam, which measures the CPU and GPU performance. For this guide, I rely exclusively on the GPU score, which measures AVC and metaverse performance. EasyBench is another relatively new benchmark on Steam which measures GPU performance. While it is still under development, you can still use it to compare the performance before and after overclocking. Before we start overclocking, of course, we have to check the performance at default settings. Please note that the Tachyon motherboard out of the box enables Precision Boost Overdrive, and that could potentially impact the IGP performance because the graphics clock frequency is governed by the very same Precision Boost algorithm that also monitors or also governs the CPU core frequency. So in order for us to know the stock performance of the integrated graphics, we first have to go into the BIOS, switch to advanced mode, enter the advanced CPU settings submenu, enter the Precision Boost Overdrive submenu, and set Precision Boost Overdrive to disabled. Then save and exit the BIOS. Here's the benchmark performance at stock. While the simple ray tracing benchmark starts up, by design it stops if you're under 2.5 frames per second for too long. Hence, we don't get a score. When running Firmark GPU stress test, the average GPU effective clock is 2190 MHz with 0.997 volts, and the GPU memory clock is 2400 MHz. The average GPU temperature is 38.4 degrees Celsius. The average GPU plus SoC power is 38.543 watts. A quick word on the difference between the GPU clock and GPU effective clock. Since Carrizo in 2015, AMD employs a couple of proprietary clocking techniques, including adaptive voltage frequency scaling, AVFS, and voltage adaptive operation, VAO. The long story short is that the combination of AVFS and VAO will dynamically adjust the frequency based on the effective voltage. The advantage is that in case of a sudden voltage droop, the CPU will not crash because the effective frequency is tied to the effective voltage. The disadvantage is that the frequency is not deterministic and may fluctuate under load. That's why I report on the effective clock frequency instead of the set clock frequency. In our first overclocking strategy, we make use of the AMD performance enhancing technologies called PBO or Precision Boost Overdrive and EXPO or extended profiles for overclocking. With the launch of Zen 3, AMD introduced an improved version of the Precision Boost Overdrive Overclockers toolkit. They shockingly called this Precision Boost Overdrive 2, and it came with a bunch of advanced extra features for tuning the Precision Boost boosting algorithm with even more detail. Precision Boost Overdrive 2 builds on the PBO implementation of Zen 2. In addition to the platform overclocking knobs from Zen Plus, PPT, TDC, and EDC, and processor overclocking knobs from Zen 2, Boost Override, and Scaler, Precision Boost Overdrive 2 introduces Curve Optimizer. While most people know Curve Optimizer as a way to undervolt the CPU cores, there's also a GFX Curve Optimizer to undervolt the integrated graphics. We'll get back to that in OC strategy number 3. There are essentially 3 levels of Precision Boost Overdrive. AMD's stock values, which can be set by disabling PBO, the motherboard vendor values, which are programmed into the BIOS to match the motherboard VRM specification and can be set by enabling PBO, and custom values, which can be programmed by the end user. In this overclocking strategy, we are just enabling Precision Boost Overdrive, whereas in the following strategies, we'll explore tuning the parameters. We find that the following values have changed. The parameter relevant for our overclock is the PPT limit, which is the total power the processor can draw from the socket before the boost levels off. Note that there are SoC specific limits for TDC and EDC. However, unfortunately, I was not able to find its programmed limits with this CPU. The Precision Boost algorithm monitors all aspects of your processor, including the integrated graphics. On APUs with powerful integrated graphics, it's possible that the graphics performance is constrained by the default Precision Boost parameters. However, since the integrated graphics in the Ryzen 7000 are so weak, we don't expect expanding the power budget to have a significant effect on the overall performance. EXPO stands for AMD Extended Profiles for Overclocking. It's an AMD technology that enables ubiquitous memory overclocking profiles for AMD platforms supporting DDR5 memory. EXPO allows memory vendors such as G.Skill to program higher performance settings onto the memory sticks. If the motherboard supports EXPO, you can enable higher performance with a single BIOS setting. So it saves you from lots of manual configuration. Upon entering the BIOS, click the XMP EXPO Disabled button. Switch to Advanced mode. Enter the Advanced CPU Settings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Enabled. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. While enabling Precision Boost Overdrive doesn't do that much to increase the GPU frequency, actually we were already running at the maximum frequency at stock, enabling EXPO to improve the memory bandwidth and latency does help a little. Unfortunately, the additional performance still doesn't allow us to complete a run of simple ray tracing benchmark. We see a maximum performance improvement of plus 12.12% in Nero GPU score. When running Firmark GPU stress test, the average GPU effective clock is 2192 MHz with 1.0 volts, and the GPU memory clock is 3200 MHz. The average GPU temperature is 41.0 degrees Celsius. The average GPU plus SoC power is 54.087 watts. In our second overclocking strategy, we will manually overclock our integrated graphics. And by manual overclocking, I mean we go into the motherboard BIOS and set the maximum possible IGP frequency. But first, before we do that, let's have a look at the Ryzen 7000 clocking and voltage topology, because that will help us better understand how IGP overclocking will really work. The clocking of AMD Radeon is similar to the previous generation of Zen 3 Vermeer desktop CPUs. The standard Radeon platform has a 48 MHz crystal input to the integrated CGPLL clock generator. The CGPLL then generates a 48 MHz clock for the USB PLL and a 100 MHz reference clock for the FCH, which contains the CCLK PLL for the CPU cores and several SoC PLLs. The SoC PLLs include a wide range of PLLs present on the I/O die, including the GFX clock for the integrated graphics. At stock, the graphics frequency will go up to 2.2 GHz during a 3D load. If you want to overclock the integrated graphics, since AGISA 1004, you can set the desired frequency in the BIOS directly. Alternatively, but I wouldn't recommend this, you can increase the reference clock frequency when it's in iClock or eClock 0 mode. iClock refers to using the standard internal CGPLL. However, in addition to the standard internal CGPLL, Radeon supports up to two external clock modes. These are called eClock 0 mode and eClock 1 mode. In addition to the graphics core frequency, there's two additional frequencies related to the integrated graphics: SoC frequency and VCN frequency. They run standard at 1200 MHz. Unfortunately, there's no way to adjust these frequencies, which will limit our performance improvements in, for example, handbrake. From the voltage topology perspective, there are a few minor changes compared to Vermeer. Like Vermeer, the processor still relies on an internal and external power supply to generate the processor voltages. There are four primary power supplies from the motherboard VRM to the processor: VDD-CR, VDD-CR SoC, VDD-CR miscellaneous, and VDD-IO MEM. I have covered the details extensively in my Radeon overclocking launch video. The VDD-CR SoC voltage rail provides the external power for multiple internal voltage regulators on SoC for the various IP blocks, which include the memory controller, the SMU, PSP, graphics, and so on. VDD-CR GFX provides the voltage for the GPU cores on the I/O die. The voltage rails can work in either regular or bypass mode. In regular mode, the voltage is managed by the integrated voltage regulator and derived from the VDD-CR SoC voltage rail. If the integrated VR is disabled and set to bypass mode, the voltage is equal to the VDD-CR SoC voltage rail. In the past, the VDD-CR GFX voltage rail would automatically switch to bypass mode when you manually adjust the GPU frequency. However, as we'll find out soon, that's not quite the case with the Ryzen 7000 integrated graphics. To manually overclock the Ryzen 7000 integrated graphics, we can adjust the GFX clock frequency in the BIOS. Simply input the desired frequency, save and reboot, then stress test the GPU to see if it's stable. Note that the integrated graphics has its own factory-fused voltage frequency curve, which scales up to 2600 MHz at 1.25 volt. When you adjust the frequency, it will automatically adjust the voltage as well. Beyond 2600 MHz, the voltage remains at 1.25 volt. For my testing, I was able to reach 2975 MHz at 1.25 volt. Upon entering the BIOS, click the XMP EXPO Disabled button. Switch to Advanced mode. Enter the Advanced CPU Settings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Enabled. Leave the Precision Boost Overdrive submenu. Leave the Advanced CPU Settings submenu. Set GFX clock frequency to 2975. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. With a GPU frequency increase of about 35%, we expect the performance to increase substantially as well. That's precisely what we see as most benchmarks scale nearly linearly with GPU frequency. We get a maximum performance increase of plus 34.96% in FluidMark. Notably, we can now complete a run of simple ray tracing benchmark and put some numbers on the board. When running FurMark GPU stress test, the average GPU effective clock is 2949 MHz with 1.245 volts, and the GPU memory clock is 3200 MHz. The average GPU temperature is 47.1 degrees Celsius, and the average GPU plus SoC power is 63.517 watts. In our third overclocking strategy, we will use GFX Curve Optimizer to further increase the GPU frequency. To be honest, this strategy is kind of a last-minute addition to the video. Originally, I had only planned for the two overclocking strategies, but when I was putting the final touches to the script, I realized that the graphics voltage wasn't in bypass mode, as you would normally expect when manually overclocking the graphics frequency on APUs, for example. And I figured it out because the SoC voltage was running at 1.4 volt and the graphics voltage was running at 1.25 volt, not 1.4 volt if it was in bypass mode. So that got me thinking. Clearly, if it's not in bypass mode, the graphics voltage is still governed by the Precision Boost algorithm. So we could use tools from the Precision Boost Overdrive toolkit to maybe further improve the graphics frequency. As I mentioned already, Curve Optimizer is a very important addition to the Precision Boost Overdrive 2 overclockers toolkit. We primarily know Curve Optimizer for tuning the CPU cores, but there's also something called GFX Curve Optimizer for tuning the integrated graphics. GFX Curve Optimizer works very similar to the Curve Optimizer that we know. Setting a positive offset will increase the voltage, and setting a negative offset will decrease the voltage. In this chart, you can see the voltage behavior with a negative and positive offset. As you can see from the chart, with a GFX Curve Optimizer of plus 30, we can increase the graphics voltage to 1.4 volt, equal to the SoC voltage. That extra voltage enables us to further increase the graphics frequency to 3.1 GHz. Upon entering the BIOS, click the XMP EXPO Disabled button. Switch to Advanced mode. Set GFX clock frequency to 3100 MHz. Enter the Advanced CPU Settings submenu. Enter the Precision Boost Overdrive submenu. Set Precision Boost Overdrive to Advanced. Set PBO limits to Motherboard. Enter the GFX Curve Optimizer submenu. Set GFX Curve Optimizer to GFX Curve Optimizer. Set GFX Curve Optimizer sign to positive. Set GFX Curve Optimizer magnitude to 30. Then save and exit the BIOS. We reran the benchmarks and checked the performance increase compared to the default operation. With a graphics frequency now running 40% higher than stock, we get a maximum performance improvement in most benchmark applications. We see a maximum performance improvement of plus 41.67% in Tomb Raider. When running Firmark GPU stress test, the average GPU effective clock is 3100 MHz with 1.395 volts, and the GPU memory clock is 3200 MHz. The average GPU temperature is 52.8 degrees Celsius. The average GPU plus SoC power is 60.689 watts. Alright, let's wrap this up. I am fully aware that overclocking the Ryzen 7000 integrated graphics does not turn it into a viable option for 3D gaming. However, as I said at the very beginning of this video, I'm a SkatterBencher, so I'm compelled to overclock anything that's overclockable, including a very low compute power integrated graphics. And to be honest, it was actually a lot of fun because, well, we reached 3.1 gigahertz, and that's almost 1 gigahertz more than the 2.2 gigahertz at stock. Furthermore, the performance scales nearly linearly. So we increased the graphics frequency by 40%, and in some benchmarks, we see performance improvements of almost 40%. That's actually kind of exciting. And the irony of Radeon Graphics integrated overclocking compared to Radeon Graphics discrete GPU overclocking is that the experience of the integrated graphics overclocking is actually quite a lot better than the experience or the overclocking experience of discrete graphics overclocking. In fact, I would say if we would have a similar kind of a toolkit on discrete graphics like we have for integrated graphics, boy, the AMD Radeon discrete graphics would look a lot more interesting to diehard enthusiasts or overclocking enthusiasts like myself. Anyway, that's it for this video. I thank you for watching, and I want to thank my patrons for the support. As per usual, there will be a written version of this video up on my blog if you want to read through the settings or check the performance results. As per usual, if you have any questions, feel free to drop them in the comment section below, and see you next time.